Okay, today we're going to be doing section 5.5, which is talking about coordinate geometry. And we just need to do a little bit of review, and that is of a coordinate plane. So remember, a coordinate plane is made up of two axes, the x-axis and the y-axis. So we're going to be focusing on those today for the section. So there is one definition that we need to get down, and that is slope. And slope shows steepness of a line. So what I like to think of is like a mountain, okay? When you're going up on a mountain, you're having an incline, that's steepness, and when you're descending on a mountain, that's a decline. So we can actually have four different types of slope. So I'm going to make four coordinate planes. So that I can show you all of them. The first is just like I said. We can have a line where we could have two ordered pairs and we can just connect those points. And this would be a positive slope. Because, as you can see, we're having an incline here. You read this left to right and we're going upwards. The next one you can have is a decline. So if I have 2 points and I connect them and make a line through them, this would be a negative slope. Because if you look at it from left to right, it is going downwards. The next one that we can have is if we can have a vertical line, or excuse me, a horizontal line. Any horizontal line will have a slope of 0. And I think of this like a floor. Okay, when you're walking on a floor, like in our classroom, your elevation is not changing. You're not going up, you're not going down. And then finally we can have a vertical line, one that goes like this. And this I think of like a wall. There's no possible way that you could just go walk on a wall right now. So this has a slope of undefined. So these are the four different types of slopes that we are going to look at today. And there's one way that we're going to focus on how to find slope. And this is probably the most important part of today's lesson. We are going to use what's called rise over run. And I like to think of this as I have to stand up before I can run. Okay? You can think of this as the vertical change over the horizontal change. Or you can think of this as up and over. And we're going to show you some examples on how to find this. Okay, what we're going to do is we're going to use this figure over here, or this coordinate plane, to help us find different slopes. So the first slope that we're going to look at is line KL. So if I look here, here is K and here is L. So if I just look at this right away, if I read this from left to right, I'm seeing an incline. So I know that this is going to be a positive slope. But what I'm going to do is I'm going to start at this K and I'm going to do rise over run. So I'm going to count up, 1, 2. So I went up 2 and I'm going to go over 1, 2, 3, 4. So I went up 2 over 4. Now we can simplify this fraction. We always put it in simplest form, and slope will always be written as a fraction. So we can reduce this to 1/2. Alright, let's try another one. Let's try line LM. So if we would look here, here is L and here is M. And I'm seeing a vertical line. So again, I'm thinking like a wall. And there's no way I could go walk on a wall. So this slope is undefined. Alright, these next two I want you to try on your own. this first one that I want you to try on your own is line LN. See if you can find the slope of LN. You should have noticed that L and N is going down. So right away we should have noticed that this is a negative slope. If I start at N, I'm going to count up 1, 2. And since I'm going to the left, that's towards the negative numbers, this is over negative 1. So 2 over negative 1, we can just rewrite this as negative 2. Alright, the last one that I want you to find is line KM. Alright, what you should have noticed is that KM is right here, and we have a horizontal line, which is like the floor. So our slope is just 0. Okay, we need to get 2 pieces of information down, and that is about parallel lines and perpendicular lines. Alright, parallel lines, remember if we look at a coordinate plane, parallel lines never touch. So for example, they're going to look like this. So what you need to know about parallel lines is that they have the same slope. So that slope is always going to be identical. If we're talking about perpendicular, remember this is a 90-degree angle. So if we have a coordinate plane, I'm going to have one line that's positive and one line that's negative, or one that's horizontal and one that is vertical, and we make that 90-degree angle. So what perpendicular lines have are opposite reciprocal slopes. And what this means is if I have a slope, for example, of 4 over 5, the opposite would be, I would go from a positive to a negative, so negative 4/5, and then I would take the reciprocal of that, which would be negative 5/4. So these two are opposite reciprocal. See if you can find the opposite reciprocal of negative 4. What you should have done and said, okay, well the opposite of negative 4 is a positive 4. And this is the same thing as 4 over 1. So the opposite reciprocal of negative 4 is positive 1/4. These two are opposite reciprocal. Okay, so from this graph, we want to figure out which lines are parallel. And it's not as easy as it looks. So what we're going to do is we're going to find a slope to every line. So let's start with line PQ. So if I look here, here's P and here's Q. I'm going to go up 1, 2, 3, 4, and over 1, 2, 3. So the slope for PQ is 4/3. I want you to find the slope for the following. See if you can find the slope of RS, of line RS, line AB, line PA, line GH, and line XY on your own, and then compare them to mine. So what you should have found for RS is 5 over 4. For AB, you should have done 4 over 3. For PA, you should have gotten negative 3 over 3, which equals negative 1. For GH, you should have gotten negative 4 over 5. And for XY, you should have gotten negative 7 over 9. Now remember, parallel have the same slope. So we can say that line PQ is parallel to line AB. Which two are perpendicular? Remember, perpendicular is opposite reciprocal. So which ones are opposite reciprocal? See if you can figure those ones out. Alright, you should have said that line RS is perpendicular to line GH because 5/4 and -4/5 are opposite reciprocal. Alright, what we're going to do next is we are going to find, using these shapes, we are going to give all of the names that apply to each quadrilateral. So you might want to use the reference sheet from 5/4 to help you with this. So if I look at A, they're already giving you your slopes. I notice that the slope on top is 0 and the slope on the bottom is also 0. So those slopes are the same. Same on the side. If we count up the sides, or on the sides, we get 1, 2, 3, 4. And I'm also going to get 1, 2, 3, 4 on both sides. So I know all of these sides are the same. So if we all know they're all the same, and the slopes are all the same, we can say that this is a parallelogram because they're all parallel. We can also say that this is a rectangle because of the 90-degree angles. This is also a square because the side and the angles are all the same. And finally, it is also a rhombus. Alright, let's try B. Alright, so I notice that, again, my slopes are the same on both sides. So across from each other are the same. And that makes them parallel. So this is also a parallelogram. Now, since these are perpendicular to each other, these are also perpendicular because they're opposite reciprocals, as were these, they create that 90-degree angle. So if these are all 90 degrees, we know that this is also a rectangle. This would not be a square because our sides are not all the same. See if you can do C and D on your own. Alright, so what I noticed for C is, again, my slopes across from each other are the same, which means that these are parallel lines, which makes this a parallelogram. I do not have a 90-degree angle anywhere, and my sides are not all without that 90-degree angle. It's not a rectangle, which makes it not a square or a rhombus. So this just falls under parallelogram. Alright, if we look at this one, alright, looking at D, I notice that my slope of this line and this line are the same, which makes these two lines parallel. These are not the same, nor are they opposite reciprocal, so these are not perpendicular. So we have one set of parallel lines, which makes this a trapezoid. Since it's only a trapezoid, it doesn't fall under any other categories, so this is the only one it is. Alright, from here you can now go ahead and do your exit slip. Thanks, guys.